Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm here with Natasha Kostenuk, the founder and CEO of Ayrton Energy. Natasha and her team have developed a technology to enable the safe and efficient storage and transportation of hydrogen. This is a big deal because green hydrogen is key in our plans to decarbonize some of the biggest greenhouse gas emitting sectors like shipping and the production of steel, chemicals, and cement. But today, hydrogen, whether it's green or not, is mostly limited to being used right where it's produced because storing it and transporting it requires super high pressures and low temperatures. So unless we can make it easier to move around, the practicality of it as a fossil fuel replacement is limited. Natasha and Ayrton's solution involves combining hydrogen with a liquid carrier that renders it as easy to store and transport as diesel. I honestly don't totally understand how that sorcery works, but I'm excited to learn more about it. To introduce Natasha quickly, she has a mechanical engineering degree and spent the first almost 2 decades of her career in an oil and gas company, Trican Well Service. She started out developing new chemistry and hardware, then moved into sales and then commercialization of new technologies. The way it looks to me, looking through her background, is that she has spent her career since then being kind of the bridge between technology and business, working to commercialize different new technologies, including a green lithium extraction process prior to founding Ayrton. I also have to mention that apparently just running a climate tech startup doesn't keep her busy enough because she's also the founder and president of a nonprofit for children. Natasha, I know we're just getting to know each other, but I wanted to share that one thing I loved about you when we first met was how incredibly humble you are, despite all of the amazingly impactful work you're doing. So thanks a lot for making time alongside all of that to hang out with me today.
Thank you. I'm super excited to be here. Yeah, I'm very excited. Thank you for having me.
All right, me too. So I'd love to start with your background and maybe just back to the beginning of career. How did you get into the oil and gas industry initially?
Yeah, so I basically was going to school here in Calgary, the University of Calgary, and I was in just mechanical engineering. And I applied for a summer job at an oil and gas service company. I was waitressing before that, and I'd say an engineering job beats waitressing most days of the week. And I decided to give it a try. I had no plans before that to get into oil and gas, and nobody I knew was in oil and gas. I didn't have any family in oil and gas. It was kind of something totally new to me, but I thought I'd give it a try. And I ended up working that summer for a company called Trican Well Service, and I absolutely loved it. I absolutely loved the people, and I loved the business, and I loved that fast pace of oil and gas service side of things where you're constantly doing different operations and troubleshooting and figuring things out. And I don't know, I think I just got a bug for it. And I ended up staying on part-time while I was going to school after my summer there. And I ended up changing my degree and adding a petroleum minor to my degree and kind of got stuck in oil and gas for a while after that, just because I really fell in love with it.
Yeah, I mean, 19 years, right? At that company.
Yeah, it was a long time. It was kind of like the place I grew up is kind of how I think about it, because I was so young and just out of school when I really started there and got to see a lot of big changes in that along the way. Got to see us moving towards greener chemistry and more environmentally friendly operations and bigger operations and more complex operations as the years went by. And yeah, really, I always was kind of one of those people to volunteer for special projects right from early. And it got me involved in a lot of really cool projects, new technology, new chemistry, helping things get rolled out to the field and working with customers, et cetera. Yeah, I really enjoyed it and learned a lot my time there.
So what motivated you to leave, or what kind of transpired to get you onto something else after almost 2 decades there?
I definitely had friends and family that were wondering over the 19 years of like why I stuck it out with one company for so long. I really liked it there. I always felt challenged. I always felt like I was being given different things to do and new challenges. And then kind of towards the end of the 19 years, they had a shift in the company and they were doing less of a focus on R&D and kind of winding down some R&D groups. And they were like, no problem, we'll move you to this other team doing more operations type stuff. And that's when I realized that my passion Wasn't necessarily oil and gas. I did love it while I was there, but I decided that my passion was more about new technologies and kind of helping explore channel partnerships and doing licensing and distribution agreements and the kind of the business side of new technology. So I took a total chance and just left. I didn't really have a plan. Kind of just, I feel like jumping out without a parachute. But luckily, I landed in a spot where I was working as an executive in residence in an accelerator program here in Calgary, working with a multitude of different early stage tech companies, all developing really cool tech, mostly hardware type tech. And I was just helping them commercialize it, find channel partners, and build their business. It gave me the bug for startup life because I was kind of working along all these startup companies and getting to learn that ecosystem. It was a lot of fun.
Is that where you came across the concept for Ayrton, or how did that come about?
Yeah, close. So while I was working with different startups, I was doing some consulting on the side, and I was consulting for some different groups that were doing hydrogen projects. And so I had hydrogen on the mind, thinking about it and how interesting some of the new technologies were coming are. I think it's really interesting to seeing the hydrogen pyrolysis that's coming, that's able to use natural gas to make hydrogen. That's obviously a big deal for a place like Alberta or Texas or places that have lots of natural gas. Anyways, I met a woman and she complained she couldn't charge her Tesla and run her whole air conditioner at the same time. And I thought, that's ridiculous. I'm an engineer. I'm really smart. I'm going to go tell her how to solve this problem. And so I did some research and I found out that I'm not that smart, that she was right, that there's a challenge with the grid and getting the power that we need. So we keep adding power generation to the grid, but getting the power to where we need it can be a challenge sometimes. And all the electrify everything shifts that we're doing is putting a big strain, a growing strain on our grids. And so I got thinking that we should augment that power with hydrogen, using hydrogen generators. And so I thought I'd just go to the market and I would find fuel cells and hydrogen storage, and I would kind of put together these generators that people and businesses and industry could use to augment the grid where they needed to. That was the original concept that got me kind of down this road. And I ended up hiring my now co-founder. She's a PhD chemist and did her PhD in fuel cells. Her name's Brandy. And I hired Brandy as a consultant to help me pull these pieces together and help me use her experience in the market to find them. And we found fuel cells that could work. And we found some other really cool technologies, but we couldn't find hydrogen storage. And it baffled us. I thought for sure it existed. I thought somebody had solved this problem. And so we spent a bunch of months looking at the different ways of doing hydrogen storage. So there's compressed and liquefied hydrogen. We looked at MOFs and we looked at metal hydrides quite deeply. But we just couldn't find a good one that we thought was really good for distributed hydrogen or being able to scale up very easily. We had been looking at liquid organic hydrogen carriers, or LOHC, and that's when we got the idea that we could do our own. We'd seen a few other LOHCs and they had some pros and cons to them. And again, it just didn't feel like it was the right fit for what we thought the market needed. And so we really started with solving that problem and then coming up with a solution first. And that's how we started Ayrton Energy.
Interesting. So tell me if this is right, but it's almost like you wanted to start a company, but the hydrogen storage mechanism wasn't available to start that company. So you decided, well, let's go start a company to solve that problem.
Yep. It's funny, meet a lot of founders that like invent something. Like I discovered this and then I went and found a market for it.
Right.
And I feel like you're always struggling to find where that cool thing you found fits into the market.
Right.
And we're really lucky because you're supposed to find the problem and then find the solution. And we were driven by this problem that we saw and created our solution based on that.
Mm-hmm. Did the problem exist sort of broadly? I mean, you were starting a company that would then have this problem, but I imagine a bunch of other companies, you must have seen a bigger opportunity than supporting your future startup.
Yeah. And like every other founder, our story was pivoting kind of by degrees at a time. Just because at first we're like, well, we'll solve our hydrogen storage problem for ourselves. And then we realized, no, this is a bigger problem. And I think we've continued to dig in over the last 18 months and talk to lots of different industry people to understand where the problem is the strongest or where they have the biggest need for this type of hydrogen storage and who's moving fastest on hydrogen and where those gaps are going to be based on the growing market. Because hydrogen is kind of more emerging market. It's been around for decades, obviously, but I think the new growth is kind of more emerging and just now.
Mm-hmm. And is that driven mostly by kind of decarbonization goals?
I think so. I think it's driven by, people wanting to decarbonize and the governments and all of the incentives that people are putting in to help speed up the decarbonization. I also think that it's why now hydrogen, when hydrogen's been around for so long. And I think that there's a lot of other enabling technologies that have really improved. I think electrolyzers have improved a lot. I think there's a lot of other ways of making hydrogen, as I mentioned, pyrolysis earlier. And there's a lot more technology around using hydrogen that didn't exist. Hydrogen turbines have come a long way. Hydrogen fuel cells have come a long way. All of those things need to exist as well for hydrogen, the ecosystem to really take off. And I think that's why now is the right time, because the other enabling technologies have gotten there too.
I want to understand that a little more, or kind of the focus on hydrogen. I guess I have some naive questions about hydrogen generally. Like, why is it hydrogen instead of electricity electrifying some of these really hard to abate sectors we talk about?
Yeah.
And is it about generating heat? And then if that's the case, why can't we generate that heat with electricity? Why the focus on hydrogen?
Yeah. And I'm definitely not one of those founders that's going to be like, everything needs to be hydrogen. I do believe we need a balance. And I think we need electrification. And I think we need other things like hydrogen. But electrification is really hard. It's the infrastructure. It's not built to handle this electrify everything shift that we're doing. The infrastructure, if you read some of the studies, they say that it's billions and billions and billions of dollars of infrastructure upgrades that need to happen, in addition to all the billions of dollars in generation that need to happen. And moving and upgrading that, like moving energy with electrons and adding that infrastructure is just very expensive and very difficult to today's existing infrastructure systems. The densely populated areas that need all that energy, it's very hard to upgrade and make changes to that. So it's going to happen. Like some of it will be upgraded and there is some upgrading happen, but it cannot meet all of the needs. There's going to be a gap. And that's where we think hydrogen can play a part in filling that gap.
So if I'm understanding correctly, like take a steel manufacturing plant, if we could adequately supply electricity, if we had the infrastructure to do that, it could be used to do what hydrogen will otherwise do.
Yeah, I think it would be very expensive and difficult to
Okay.
get to that level of power to replace all of the gas that's going to those facilities. It would be incredibly impractical, I think, to electrify really heavy duty industry. It's very hard to decarbonize through electricity with heavy duty deep industry like that.
Got it. And it comes down to just the kind of supply of that electricity is really challenging. So that leads us to hydrogen. And I think I've read that something like 30% of we're projecting that 30% of our total energy usage will be hydrogen in 2050 or something along those lines.
Yeah, I've read that it's kind of a common thing that you read between a few different countries. Canada has that goal, the US has that goal, some countries in Europe have that same kind of goal of 30%. And again, it's not trying to displace everything else, it's just realizing there's going to be a gap when you try to electrify everything and use other clean fuels and clean energy, that you can't do it all with one source. The problem's too big. Big problems need multiple solutions. That's what I always like to think.
Mm-hmm. And why is hydrogen so hard to store and transport?
Yeah, the molecule's tricky. It's really small and it doesn't compress very well. It has a very low density to it when it's just in atmospheric conditions. So it really needs high pressure or to be cryogenically liquefied to really do transportation. That's how things are done today. So high pressure, like typically stored between 200 and 700 bar, with most of it around 300 to 400 bar pressure. And even at somewhere between 350 and 700 bar, you're getting between 20 and 40 kilograms per cubic meter. So I'm Canadian, I always speak Canadian units. I'm sorry, I'm not always good at translating them.
Well, that's good.
But it's relatively low density, hydrogen density. Liquefying hydrogen gets you about 70 kilograms per cubic meter, but you have to bring it down to almost absolute zero. And that takes a lot of energy to get the hydrogen to that cold before it will liquefy. And then you have to hold it at those temperatures. And you have to allow it to have some release, which is called boil off in that case. And you lose about 1% of the hydrogen a day just from sitting there when it's in a liquid state. And both liquefied and compressed require specialized equipment. They need tube trailers or special storage vessels to be able to contain the hydrogen. Hydrogen itself causes issues with the metallurgy. It reacts with the metal and causes embrittlement issues. So you need special materials to hold it, or else it's going to eventually cause issues and leak from your container. So you need all of those things. And yeah, those combined, it's tricky. It's complex. It requires all this expensive infrastructure changes and vessels and everything to be made. And then it, of course, has safety concerns because when you've compressed hydrogen or have it in a liquid state, it can be dangerous. And again, as an industry, we know how to manage safety risks, but they always come at a cost.
Yeah, but at the end of the day, we're just trying to get hydrogen as cheap as possible, and all of these things just add extra cost. Yeah, I was also reading that the hydrogen that leaks into the atmosphere actually has a global warming effect that's like 10 or 11 times higher than CO2.
Yeah, I've read that too. So we definitely don't want to have leakage of hydrogen as much as we can. We want to use it and not have it leak into the atmosphere.
Right. I guess is that just it that leaking is a risk partly because it's such a small molecule. It's hard to contain it like if we were to put it through existing pipelines, that kind of thing.
Yeah, it's very tricky because it's such a small molecule and it reacts with the metal and causes embrittlement issues, which then cause basically leaks and holes to happen in the metal. So to be careful there for sure. So that's what led us to develop this LOHC or liquid organic hydrogen carriers. Basically, as you mentioned earlier, we take hydrogen gas and we chemically bind it to the carrier oil. The carrier oil acts like a sponge that soaks up and releases the hydrogen. And when it's holding the hydrogen, it's a room temperature and room pressure liquid that can be stored and managed no differently than diesel or gasoline. So anywhere diesel can go, we could put this liquid. You can reuse existing tanks, trucks, pipelines, and rail cars. So you don't need new infrastructure. And it holds it at a high hydrogen density of about 55 kilograms per cubic meter. So almost 2 times higher than most compressed hydrogen storage and just a little under liquefied hydrogen without the need to buy expensive tanks. The same safety concerns because you're just storing it like you do diesel. It doesn't boil off. It doesn't leak. It doesn't do any of those things. It contains it for a long time.
And is that liquid carrier, is that something novel that you and your co-founder developed, or where does that come from?
Yeah. So basically how it also works is when you are ready to use the hydrogen again, we do the reverse reaction where we chemically remove it from the carrier oil and the carrier oil is returned and recycled over and over again like that sponge. And so the common way of doing this today is using thermocatalysis. And that's what other competitors in this space are doing with LOHC is this thermocatalysis process, which is a little bit like Haber-Bosch for ammonia. It's a process that's been known for decades and is really well understood. And it's basically like a chemical plant. And so you use high pressure and high temperatures like 350 to 400 degrees Celsius to be able to store and release the hydrogen. In our system, we're using electrochemical reactors at a low temperature, which enables us to do everything at 60 to 80 degrees Celsius. So significantly lower temperature enables us to release pure hydrogen as opposed to having to purify it after it's released from the oil. It allows us to reuse that oil carrier more and more. But the oil carrier that we're using is not a special molecule that we've made. Based on my background, I realized that scaling up specialty chemistry can be a barrier to scaling and scaling fast. And so instead, we're using a mixture of commodity products that are available in large quantities anywhere. That's where we get our oil from.
So you don't have kind of future supply chain challenges as you scale?
No, yeah, as a startup, we're going to have our own challenges. And so I didn't want to add extra challenges I don't need to add. So trying to keep it as simple as possible. The KISS method, we keep it simple.
Mm-hmm.
And so anything we can do along the way to simplify our design or simplify our supply chain is a choice that we're making.
And as I understand it, that the oil is not a consumable. So it's something that just gets reused, infinitely, indefinitely?
Just reused over and over again. Yeah. Thousands of times you can reuse the oil.
From a hardware perspective, what's going on and what does the system look like?
Yeah, so as I mentioned, it's an electrochemical reactor. So it would be very similar to other electrochemical systems. The ones that people know of the most often are usually fuel cells and electrolyzers. And so our system scales in a very similar way, which stacks cells, stacks of stacks, and can scale up very large sizes of operations and large systems in a very similar way. So we see electrolyzers scaling up to megawatt or gigawatt size, and our system can scale up very similarly.
Are there places where you have to innovate in the hardware, or are you able to buy off the shelf or buy existing components and integrate them?
I wish we could keep it super simple
Yeah.
of just buying it, but we can't. No, it basically, we had to make some modifications to the typical, like we're able to leverage wide learnings of the industry for electrochemical systems, but we had to add some modifications to it to make it fit for purpose for our reaction that we're doing. And those modifications are novel. And so that's really what we're having our secret sauce around is kind of those modifications to the system and then the proprietary blend of our chemistry that we're doing.
Got it. Where are you in that kind of technology and hardware development process? Do you have prototypes or pilots with customers? Where does that sit?
Yeah, so we've been doing lots of lab prototyping in the last year. We were really lucky to work with a group out of New York called SOSV and Hacks. I'm not sure, hopefully I'm allowed to mention them here, but they were really great for helping us. They have a team of engineers and supply chain people that helped us kind of do increase the cycles of learning and the speed of our cycles of learning with building prototypes quicker and for lower cost. So if you can do a prototype for a couple $100 in a couple of weeks, you should build them every couple of weeks and just keep iterating on those prototypes. And so that's what we really spent the last year on, was just rapid prototyping and scaling up our system and improving the design. And so now we are at a scale where we're going to be doing our first pilot project in a few months with a local gas utility. And so that first one is still small size. We're going to be starting from our lab scale now. And by the end of this year, we'll be at 30 kilograms a day of storage and release.
Does the same?
It's small,
Okay.
but next year we'll be at 10 times that because, again, it just stacks. So once you get the base system kind of operating, then you can stack it. We can be at 300 kilograms the next year and then 3 tons a day the year after that. So
Okay. So you'll build lots of these smaller modular components and then can kind of stack them depending on how big the needs of your specific customer are.
yeah, exactly.
So you'll end up being in the business of producing lots of the same thing over and over, which is good.
Seems like an easier path to me than building a custom chemical plant every time somebody wants to do something. So it feels like that's, again, easier path to scaling.
Yeah. It's a trend I hear over and over, or like a strategy I hear over and over in the climate space and probably everywhere. I mean, that's how solar scaled and came down the cost curve. And so many other companies are taking that approach. It makes a lot of sense.
Yeah, I think that's definitely, and I know it makes it sound easier, and our team hates when I say things are easy because we're definitely solving hard problems. But yeah, it's definitely the easier path when you can make things in a modular way.
And then what's your business model? Who are your customers and what will you sell to them?
Yeah, so we're focusing on 2 types of business models. One is a licensing model. And so working with fuel cells and electrolyzers to be directly integrated with them. We are working on some projects, like we're in early planning stages of some projects right now with fuel cells and electrolyzer companies. We think we could license our technology too. And then the other side is our customers are asking us to own and operate the equipment and to operate it over a long-term contract for them at their facilities. So that's kind of our business model, is to do an upfront installation fee, for example, and then a monthly user fee.
And then if I understand it right, so you would take hydrogen from a central hydrogen production facility. You're not in the business of producing hydrogen. You would take the hydrogen, combine it with your carrier, transport it to your customer's site, feed this combined oil, your carrier plus hydrogen, this oil into your system, and it would break it back into oil and hydrogen, and they would use the hydrogen for whatever their use is. So you're basically providing pure hydrogen out of your black box to them.
Yeah, for sure. Another use case, though, doesn't even require any transportation. So a lot of facilities are looking at decarbonizing, say, like an ammonia plant, for example, by using green hydrogen to do that. And so the way you make green hydrogen most often is from wind or solar. So it's intermittent use. It's not going to be available 24/7. And then ammonia plants require to be operating 24/7. So you need to be able to make more hydrogen every time you are making hydrogen and store that extra hydrogen in a buffer tank so that you can constantly feed an ammonia plant, for example, at a consistent rate. And right now that's using expensive compression equipment and compression storage for hydrogen, which is very expensive. And our system simplifies that and can provide that at a much lower cost for doing the same thing. So really that long duration hydrogen storage or long duration energy storage is looking to be a really attractive part of the market for us.
Okay, got it. Does the same piece of kit combine the hydrogen and the carrier as split it apart? Is it the same system?
They're very similar. And in long term, we think we can optimize it for being able to run a single unit in reverse so that you can do the same piece. But right now they are slightly separate. And so we do have different units for that. But our long-term vision is to think of building as a single kit that can do it in reverse.
Mm-hmm. The US Department of Energy at least has this energy earthshot effort with a goal to get the cost of green hydrogen down to $1 per kilogram. So I'm just curious, like, how does the cost of what you're doing factor into that? I assume that's a just produced hydrogen cost target. It has nothing to do with it being stored or transported anywhere. But how do you look at sort of the unit economics and the impact your system has on it?
Yeah, so our goal is to be able to store and release the hydrogen for less than $1 per kilogram as well, so that we can keep those costs down. Right now, some of those transportation costs and storage costs can be 5 or 10 times higher than that, depending on the application that you're using, equipment. So we're trying to get that down to an amount that makes it easy for people to adopt hydrogen. I think the cost of storing and releasing is something that people have a little bit of an afterthought. People have been really focused on hydrogen production technologies and really focused on hydrogen end use technologies, but we think the bottleneck to broader hydrogen adoption is really the storage and transportation piece.
Mm-hmm. Maybe this is a stupid question, but why not produce hydrogen in a more distributed way? Just a lot of small hydrogen production facilities all over the place.
Hard to get the costs down if you're doing it in a distributed way. Yeah, if you really get costs down to like that dollar per kilogram of production that they're trying to target, you need scale to do that as well. And so that makes it a lot harder. And also you need to be paired with a clean source. So you're either using solar or wind for a lot of hydrogen production that's clean, or as I mentioned before, doing natural gas. And so then you're around the natural gas facilities really to make that work. So distributed hydrogen is very tricky.
I think when we first talked, another use case you talked about was data centers and doing energy storage.
Yeah, we've had a few conversations with some different groups about data centers. So data centers have a couple of challenges depending on where you are in the world. Some of them are challenged because they use diesel generators as backup, and they create more emissions just during the maintenance of them than they do in the actual operation of them. So it's kind of a waste of emissions. And so if we can look at replacing the backup diesel generators with fuel cells, but you need to be able to store hydrogen safely for a long time without those losses. And footprint can sometimes be a concern. So having a smaller footprint with higher density is important. And then there's some parts in the world where they're trying to rapidly expand the number of data centers that they have. And access to grid power is really limited. Getting enough extra power to develop these centers is tricky. And so they're looking for behind the meter solutions that are clean. And so putting it next to a wind power plant or a solar power plant, you're challenged with the intermittency of those to be able to be reliable for the data center. So that's where the energy storage comes into play, and using hydrogen for that, or just importing hydrogen for certain countries that they don't have the footprint to be able to put solar or wind next to a data center. So they want to be able to import a clean fuel. And hydrogen's high on the list of a clean fuel that fits for that.
So actually using it as in some cases, the primary power source rather than a backup.
Yeah, for sure. It depends on the market you're in, and obviously economics are going to play a part. I always think that people have good hearts about wanting to decarbonize, but at the end of the day, economics still come in and factor into everything that we do.
Well, it makes me wonder with this kind of boom, this generative AI boom and all the new crazy predictions about how many new data centers we're going to have to deploy. Does that kind of change your strategy or your outlook on your commercial path?
Yeah, I think the energy demands are just going through the roof. I like to use an example of light bulbs. And so when LED lights first got invented, people replaced their single string of Christmas lights with a hole covering their whole front of their house with LED lights because they were cheaper to run.
Mm-hmm.
But so you're not using any less energy. You're using the same energy. And sometimes you're even using more, even though per light bulb, you're using less energy. And so I feel like as a whole, we keep making things more energy efficient, but our appetite for energy is just continuing to grow. And that's not going to go away anytime soon. So I do think there's going to be a large demand for more things. And data centers are one of the areas that are feeling that a lot. I'm not an expert, obviously, in data centers or AI, but I've seen some graphs where they had a projection from 5 years ago at the growth of data centers and compared to the new projections of data centers even 5 years later. And they're like, how are we so wrong? So there's definitely growing huge. Yeah.
Yeah. Which should be good for your business, it sounds like.
I think so. Yeah, I think it's good for energy businesses for sure.
Kind of a tangent, but this concept of as energy gets cheaper or cleaner or things get more efficient, we're just going to use more of it. Do you feel like that is an okay thing? As society evolves, we should just support more and more energy use? Or should there be more focus on behavior change and consumption change and things like that to kind of reduce the demand?
That's a tough question. I'm not even sure how to answer that because it feels like as we continue to use and create new technology, it always has a higher energy demand. I think about how many laptops are in your house. 10 years ago, you might have had a home computer that your family used. And now I think some of my kids probably have 2 laptops each, and an iPad. And there's just so many devices in everybody's houses. And so at what point when we say we have to be more responsible with our energy use, do you say you can't use new technology, right? So I think that's the hard part is who chooses who gets to use the new technology. I don't know. I don't have an answer for that. Sorry. It's a tricky question, though. It's a good one.
No, it's a tough one. I think about it a lot. Where are you on the commercialization path? Can you say more about how mature your commercial relationships are and what that looks like?
Yes, the demand has been overwhelming. People calling us interested in what we're doing, which has been a good problem. It's good that we are, people are interested in what we're doing and wanting to talk to us. Still a challenge for our team because we have to figure out what use cases do we feel we're the strongest in. And so we've done a lot of work over that in the last year to narrow down our focus and what areas geographically do we think hydrogen is going to have the strongest market size in, at least in the near future, so that we can commercialize there first or balance any political risk that there might be in the hydrogen markets and figuring out who is really interested in hydrogen. So some people are tire kickers on hydrogen and some people are tire kickers on maybe LOHC. And so it's just having more in-depth conversations to kind of figure that out. But we've been really lucky to grow some really good relationships with some companies. And so we believe that we're going to have at least one larger pilot next year. So I mentioned the one we're doing this year at about 30 kilograms a day is the target size. Next year, it'll be 300 kilograms a day target size. And then we've actually had a few people reach out to us for some commercial opportunities at 3 tons a day in 2026, early 2027 type timeframe. So that's kind of our target, is to start early commercialization in that timeline.
What are the things that keep you up at night, or what are the big challenges you see in getting there?
One of the things that keeps me up at night is team and making sure that we always keep our team. I love our team. I think we're doing amazing things and we got to continue to grow our team. And so keeping our culture and keeping that team feel going forward as we continue to grow is a challenge. And I think we live in a fairly large market, a city in Alberta, but attracting all the right talent and keeping them in our market is also going to be a challenge as we continue to scale. So that's one thing that definitely keeps me up at night. And yeah, other than that, I don't know, that's the number one thing that I worry about is the team and scaling the team. Some people say that there's concern about hydrogen and how big the market's really going to be. And I'm less concerned by that because I do think that even if the market's slower to grow than some of the forecasts are or we're predicting, there's still going to be a need for hydrogen storage. And I think it's an area that's been underinvested in. And I think there's going to be a need for what we're doing and we can continue to solve that problem and help the market continue to grow.
How big is your team now and what are your growth plans?
Yes, we have 10 right now on the team. And a year ago, we were 3. So that's a pretty big growth. And then at the end of this year, we plan to be closer to 20. And then I have a hard time picturing exactly how big the team's going to get a year after that. But I would imagine between 30 and 40. So it's lots of plans to continue to grow and adding to our team, looking for the right people. And sometimes we are very impressed with some people that just kind of reach out to us. And we've been really lucky to have a lot of people come to us to want to join our team or get introduced to us through our network. So always put that out there. If you think you're a fit, you should call us.
What about on the technology side? Are there any risks ahead that are going to be challenges?
For sure. Definitely. If our tech worked right out of the box, that would be ideal, but nothing works that way. I always think that if it was easy, somebody would have done this already. So it's definitely has some challenges to what we're developing, but I know our team can do it. Our team can solve hard challenges and we've made so much progress. A year ago, we were doing our reaction in a beaker with some dangly electrodes in a beaker. And now we've got flow reactors and we have we've done some little pilot testing where we can pilot and run a fuel cell off of our lab prototypes with the hydrogen that gets released from our dehydrogenation system. So we've made a ton of progress in a short time and our team is just continuing to make progress week after week.
What's your vision for Ayrton? Like what kind of the sort of future state of where you go with the company? What kind of impact do you want the company to have? And what kind of timescale is that on?
Yeah, so our vision is hydrogen everywhere. Hydrogen is common as a fuel as diesel. And it's a weird thing for us to say because we don't make hydrogen and we don't use hydrogen. But we really think we're the enabling technology to make that happen and to have that vision happen. And I can see that happening by 2050, when they say 30% of all of the energy needs are coming from hydrogen, that's where it's going to be as easy to use as diesel. That's really our target.
Okay, so I have 3 questions to close us out. The first is, how optimistic or pessimistic are you about the future of the planet and why?
Oh, I'm optimistic. I feel like as a planet, as a people, we're constantly hard on ourselves that we're doing things in a way that's harmful. But then I think we come up with solutions and we move forward and past that. And so I'm optimistic. I think we're doing the right things. I think we're talking about the right things. I think the shift has really happened. Even in the last 20 years, there's been a huge shift in people's feelings about what we're doing for the planet and how we're doing it. And I think I'm optimistic for sure.
Who is another individual or company doing something to address climate change that's inspiring you?
Oh, well, the first thing that comes to mind isn't a particular company. It's this. I'm going to do a shout out to the Women in Clean Tech program when it was Mars
Yeah.
in Toronto. So there's a Women in Clean Tech cohort, and we're about almost a year and a half into a 2-year program. And there's 10 women, 10 CEOs in this program I taken across Canada. And these other 9 women just inspire me every time we connect and chat. They're doing some amazing things. Some of them are doing milk without cows. They're doing fat without animals to enhance beyond meat type burgers and stuff. They're doing fake leather with mushrooms. I'm probably not not giving them credit for the amazing tech. I'm not describing it as well as they all do. But I just find the whole team of them to be super inspiring, and they inspire me every time we get together.
Awesome. I'd love to get some of them on the show if they're doing anything with hardware.
Yeah, a couple of them are. I can definitely do some connections.
What advice do you have for someone not working in climate today who wants to do something to help?
Take a step and I always said to people when they say, how did you pivot your career from oil and gas to this? And it took me a bit to think that it was even a pivot because it didn't feel like a pivot. It felt like just a step. Like I just took a little step and just did something I found interesting. And then it led me to another step and then another step. And then when you look back, you're in a totally different ballpark. And so that's just kind of how I did it. It's just taking a little bit of a step at a time. So I don't think you need to look for the big shift. Most career changes don't happen in a big shift. It's just about taking a little step and following things that you find interesting. So that's my advice.
Love it. Natasha, thanks a lot for your time and for everything you're doing. Appreciate it.
Thank you. Thanks for having me on your podcast. Super happy to be here. Thank you.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.